हेलो फ्रेंड्स, आज का हमारा टॉपिक है स्पेक्ट्रल सीरीज. सो दिस टॉपिक कम्स फ्रॉम एटॉमिक स्पेक्ट्रा. सो बेसिकली वेन एवर atomic gas or vapor, so from that gas or vapor, if some current passing through that gas atom gets excited, right, and just gives different types of spectral lines. So here we have some different types of spectrum, right? So on the dark background, here we have bright lines on that, right? So this spectrum basically known as absorption spectrum, and by the emission of different proper different electrons, we get this type of spectrum, right? So here total in spectral series, uh, if we use hydrogen if we use hydrogen gas to emit this type of spectrum, right? So earlier we discussed about that vapor state, so that is our hydrogen gas, right? So in this hydrogen gas, uh, this is very basic gas, we know that H hydrogen, okay? So very light atom, light nucleus gas, okay? So now whenever, because of this hydrogen gas, many different lines that we have due to the emission of that particular current. So here first of all we have, due to that spectral lines, we have first Balmer series. So in this Balmer series formula to find wavelength of that particular lines, wavelength, so this is our one spectrum, right? So one spectrum starts from R into 1 upon 2 square minus 1 upon n square, where n is equal to, which is always greater than 2, so it starts from 3, 4 and up to infinite. So this is our one spectrum which is called Balmer spectrum, and it is known as Balmer series, right? Okay, then after this Balmer, but inside this formula we have one R which is called Rydberg's constant, and that value is fixed, that is 1.097 into 10 raised to 7 meter inverse. Then our second series, which is found by Lyman, so it is called Lyman series. So Lyman series is equal to R 1 upon 1 square minus 1 upon n square, where n is equal to, here greater than 1, that means 2, 3, 4, so on up to infinite. So this is one type of spectrum. Lyman had found this type of spectrum, that's why Lyman series. Then third, Paschen. So in Paschen series, 1 upon lambda is equal to R 1 upon, this is our third series, that's why I have to write here 3 square minus 1 upon n square, where n is equal to greater than 3 means 4, 5, then up to infinite, right? So this is our new spectrum. Then fourth series, that is our Lyman, Balmer, Paschen, and the fourth, our next that series is bracket. It is called bracket series. So this series starts from, yes, 1 upon this, that is our fourth series. So here R, then 1 upon 4 square minus 1 upon n square, where n is equal to 5, 6, so on up to infinite. So this series formed by bracket, that's why bracket series. Then fifth, it is Fund series, right? So Fund series, 1 upon lambda is equal to R 1 upon 5 square minus 1 upon n square, and n is equal to greater than 6, 7, 8, right? So starting from 1 to 5, all series we have, right? So this all series for the hydrogen gas. But if we want to find for another gas, there are another gas. So starting from hydrogen, then we have helium. But helium one electrons we have to remove from that, so it becomes helium plus, then hydrogen, helium, lithium, then we have to remove two electrons. So here we are talking about only single electron having gas, right? Helium plus means only one electron, lithium double plus means only one electron, then hydrogen, helium, lithium, beryllium. So we have here three positives. That means one electron only, right? So but apart from these four gases, only hydrogen gas have these simpler forms, but for helium plus there will be complex form, for lithium more complex. So as here atomic numbers are increasing, then complexation in these equations are increasing, right? So that's our spectral series. That's it for today now. Thank you.